Yeah. Hi. In the previous session, we discussed about tree. What is tree? What is binary tree? And what is binary search tree? We already discussed those three things, and we differentiate the things. How tree is different from binary tree? How binary tree is different from binary search tree? Now, I have a question: why I need to use for tree? Because I have so many data structures in Java. Like stack is one data structure, queue is there, arrays are there, linked lists are there, so many data structures are available. Then why I need to go for trees? Just remember, stack, queue, linked list, arrays are sequential linear data structures, means there is a sequence of elements will present, so that is called linear data structure. Suppose I have a non-linear data, I have a non-linear data. For example, my non-linear data is like this. I have a data of my CEO, my company CEO, and his name and his designation. And my CEO has some authority on remaining people. So under CEO, some of the people are working like assistant CEO, manager, and architect, technical architect. Under manager, some of the team leads are working. Team lead 1, team lead 2, team lead 3, like this. Under team lead 2, some of the employees are working. Employee 1, employee 2, like this. Some my company contains this information. First CEO, in under CEO, assistant CEO, manager, some technical architect. Under manager again, some of the people will work. Team lead 1, team lead 2, team lead 3. Under team lead 2, some of the employees are working like employee 1 and employee 2. Now if you consider, so this is called data. Whatever my company data is in, like this. So I can't store this type of data in array because some hierarchy is there. So if I store this data in a array or a linked list or a stack or queue, my hierarchy will gone. My link with who is superior, who is not superior, my this type of link, this type of relation I will lose if I store this data in arrays or single linked list or some other data structure. If I store this data in linear data structures, I will lose the link. Now I want to store without losing my relationship between those data. How I can store? So I will use tree data structure. I will use tree data structures. Why tree? Why not binary tree? Because the node contains more than two elements. Then I this is called as a tree. So when in real time trees are used, if your data is in the form of some hierarchical data, not a linear data, some hierarchical data like your company organization. Otherwise, one more example for trees are, suppose I have a drive, D drive in my computer. The D drive contains folders, folder 1, folder 2, some folder 3, like this. Again my folder 1 contains some a.txt file, and my folder 2 contains some zip files, b.zip, and some c.jpg file. Like this, some data is present in my folders. So here also hierarchical. In within the D I have three folders. Again within the each folder I have some data, some subfolders or some sub files there. So if I want to store this type of data, how can I store? I need to go for tree data structures. So tree data structures in real time we will go and use for hierarchical, to store the hierarchical data. If your data is not hierarchical, then don't go for the trees. Use existing some other stacks, queues, arrays. You can go and use those things. Don't go for tree. If you have data is in the form of hierarchical, then only just go for tree data structure. Yeah. If you suppose I am using so you know why trees are important. Now why binary search trees are very important? In which situation we will use this bsts? So I have a a tree called 15. This is a BST. I have a children. So 15 has a children 7, 20. Again 7 has some 3, 10, like this. Now you can ask one more doubt, sir. If it is 3 less than 7, fine. If it is 10 greater than 7, this is a binary search tree. Now if I can I put 20 here? Can I put 20? Because 20 is also greater than 7, but you can't put, because that whatever the number that must be less than this number, and also you need to consider this one also. So the all the left hand side elements must be less than this 15. So 3 less than 15, 7 less than 15, 10 less than 15, and all the right hand elements must be greater than this element 15. So if I 18 is correct, 22 is correct. If I put in the left hand side 12 or 10, that is wrong, because if you put 12 here, it is less than 15, then your less elements are inserting at right hand of the tree, that is wrong. So every time the all the elements must be, if it is a small element, must be present at left hand side. If it is a greater large element, must be present at right hand side. That is the unique condition for binary search tree. Now why I need to go for binary search tree? So easy to find an element. Suppose if you take an array, if you take an array contains also same number of elements. So how you need to find a particular element in an array? So how you will find out that element? Suppose my array contains some data like 3, 10, 15, 20. So I want to find out an element called 15. How you will find out that element? Now directly I will go to search the element in each position. 15. It is 15. No. Then I will shift the next, go to next element. It is 15. No. I will go to the next element. Yes, it is 15. So I need to search the each and every element in an array. Suppose if it is sorted array, I will use the binary search technique instead of linear search. Means I will go to the middle element, I will search. Then whatever the way you choose, the time complexity, the searching complexity is very less here in the tree. Suppose if you want to search an element called 20, then I will go to the root element. So the 20 is greater than 15 or less than 15, I select. So 20 is greater than, so I will go to the right hand side. If again I will find that element. Suppose if you want to find an 18, 18 is smaller than 15 or greater than 15, greater than 15, so I will go to right hand side. So the 20 is there, so 18 is smaller than 20 or greater than 20, smaller, it's a small element, so I will go to the left hand side. So within the two iterations I will find the element. So searching of an element is very easy in binary search tree compared to arrays, linked list, remaining things. So if you consider in a linked list, 3 is pointing to 10, and 10 is pointing to some 15, like this, the data will be ordered. So if data is like this, now you need to go in sequential order. 3 dot next 10 will come, 10 dot next 15 will come, like this you need to search the each and every element in the linked list. The time complexity is O of n is the time complexity for linked list. The time complexity in arrays is log n. in the ordered, in the ordered array. If that, what is the time complexity? Log n. So the time complexity of ordered array is in a log n, and time complexity of linked list is O of n. Time complexity of a BST is also a log n. So searching in BST is very easy compared to other things, and insertion and deletion is also very easy. If you want to insert an element 22, 20, so 24, I will go 15. So 24 is greater than 15, so it will go to right hand side. 20 is also very small compared to 24, it will again go to right hand side. So here I would like to insert 24. So there is insertion is also very easy in BSTs compared to arrays and linked list, because if you want to insert an element at array, I will insert element here, and remaining elements I want to shift one position to the right side. So that is very complex in arrays. So insertion and deletions are very easy in in binary search tree, and searching is also very easy in binary search tree. These are the advantages. That's why for data storing purpose, if it is ordered, then we will go for BST. And tree is a recursive data structure. Suppose a tree is a combination of subtrees. A tree is a combination, it is also one tree. So it is also one tree. So it is a recursive nature. So itself it will be repeated. A tree is nothing but one or more subtrees. A subtree is nothing but one or more subtrees. Means it is a recursive itself. It is repeating for itself. So that is called recursion. If you want to traversal, or if you want to search anything in a tree, you need to go for recursive manner only. So that is the advantages with binary search trees. So that's why we are using binary search trees. If you see where we are using this tree in real time, if you have a data like hierarchical data like D drive folders, like otherwise companies, organizations, CEO, technical architect, like any hierarchical data, you can go for trees. And also you can make any information very easy to search. If it is a less, just go to the left hand side. If it is a greater than element, if go to the right hand side, you can find very easy way and manipulate the sorted list of data. So it's very easy to manipulate the sorting list of data. If the data is in the sorted ordered, then you can you can easily insert, delete anything very easily. If it is not sorted, it is somewhat difficult to find that element, but if it is a sorted, it is easy to find the element, it is easy to delete or insert anything very easy. And real time in the digital images visual effects concept, otherwise in networking routing algorithms, something algorithms, in that concept the trees are very famous. So in the real time the trees are using only if it contains hierarchical data and easy to maintain some sorted data. In that situations mostly we will use the trees concept. So in the next video we will discuss about the first program by using binary tree. Binary tree, how to print, how to write a tree with below data. Suppose this is a tree, how to build this data in a Java program. We will write a one Java program to store that information in hierarchically. Okay.